Okay, guys, so if you look up, we'll look at the next lesson. Also quite easy.
You want to do 5 hours? 5 hours?
I'll let people try it at home and then I'll do it in the next class. In the tutorial, actually. On the tutorial. Okay, yes? It does, but as part of a bigger question, to like a practical problem. So you need to know the formula. I don't think the formula's in the book. And there's two area formulas. So firstly, there's the basic formula which you learn in elementary school. So when you have a triangle here, this is called the base, and then this here is the height. Yeah, and we'll use H for height and B for base. And the formula for the area is a half the base multiplied the height. Come on, guys. I'm not going to talk while other people are talking. Come on. So, this is more just revision from elementary school, really. First example there, we'll just do 1a. So it's half the base multiplied the height. So can you tell me what the answer is for 1a? In your book there, 1a.
So 10.5. You said get the answer.
True. A half the base multiplied the height. What is it? 10.5. That's basic. However, the new formula for today, Dawn and Sherry, I've been patient and ignored you a couple of times, but you are really starting to distract me now. Okay, so if you need to work together, wait till I'm not talking. Okay? What was I saying? Oh yeah, so we have another formula for area. That's the one. This formula is good if you know the base and if you know the height. But this is in the normal situation. Normally what happens is this. You have a triangle, like this, and maybe, for example, you know this angle, I call it A, and you know this side, I call it B, and you know this side, I call it C. And the problem here is you don't know the height. Now, if you did know the height, what would the area be? It'd be a half C multiply the height. We don't know the height, but because this triangle is a right angle triangle, like what we saw earlier today, right angle triangles have special rules. What is the sign of angle A on this right angle triangle? It'd be H over C. Opposite over... C is the whole thing. H over B, sorry. Yeah, H over B. You're right, and C is the whole thing, yeah. So what does H equal? If I rearrange this, it would be, take that up, B sine A. So if I put that in there, I get area equals a half CB sine A. Or in other words, a half BC sine A. That's the area. But don't try to remember it. Yes? Which one? Say again? Is that the one with the three sides in it? We don't cover that, but you could use it. But we don't actually do it either in semester 1 or semester 2. So it would need to be a question in the exam whereby using that formula made it much quicker to do, because you should always be able to do it without using that formula. Yeah. So yeah, you can use it. I don't think it would make it any quicker though. Okay. Don't try to remember the formula like that. Instead, remember the formula like this. If you have a triangle and you know this side and the angle in between the sides. Now I'll say that again. You want the angle in between these two sides. So not that angle, this one. If you want the area, it's a half the side multiply the side multiply the sine of the angle. That gives you the area. And again, it's important that it's the angle in between the sides. So for example, in 2a, yep, gives you the area. So this is our second area formula for today. And this was our first one. So for example, if I look at 2a, this side is 10, this side is 26, we'll say, and then this angle there is 67.38 degrees. So the area is a half multiply 10 multiply 26 multiply sine 67.38 degrees. So what answer do we get? 190 exact. How well does that compare? No. 120. You said, I don't say 190, sorry. Oh, 119, yes, okay. 120. 120 is the area. And if these were meters, as an example, what unit do I need here? Yeah. Okay. The next example I'm going to do is to put the two formulas together. So this will be like 3a. Can I scroll down? Yes? Okay. So in 3a, this side is 40, and then this side is 58, and then this angle is 46.4 degrees.
Says the base is C.
Which one?
It says the base.
Oh, the base. Oh, so I've done it the other way around. The 58 should be on the bottom. I'll just redraw it. This is 58. And then, what's the other side? 58 and 40. And then the angle between them is 46.4 degrees. 46.4 degrees. And what they want for this question is they want you to find what the height of the triangle is. And you can use this using the area. So firstly, what's the area here? That's a half 40 multiply 58 multiply sine 46.4 degrees equals could be, yeah. 840, we'll just say. But what's my second formula for area? But what's the other formula for area? A half the base multiply the height, which is what I want, isn't it? And we know what the area should be. What is it? 840. So we can easily solve this to get the x. Therefore, x equals 840 multiply 2 divided by 58. What do we get? 28.97. So we'll just say 29.
No, it's 28.
Yeah, 29.
Yeah. 29. Not degrees, sorry, 29. No, not rad. It's the length of this height, 29. Meters if it was meters. Okay. Not helping to say. Not helping. Okay. I find that this is useful for the exam sometimes, because sometimes in the exam they give you the area and it's often helpful for the question to know what the height is. So it's just a little technique which I found once or twice useful for the exam, where you use both area formulas together to get the height of the triangle. It's kind of convenient. It's not the only way to do it.
Is there any way to check your answer with this?
Well, to check, I would do a half multiply the base multiply the height, make sure I get 840, and then just type this in again. There's not really any other way to check it. You mean to confirm if the answer is right? Yeah, I'd say you could just do it roughly. So if this is 40 and this is 58, you expect a 2-digit answer here. So, I mean, that's the best I can really do. I mean, you shouldn't expect something like 200, you know. Okay, 4 now, 4a. So in this one, I give you the angle, yeah. So I give you 25, 52, and I want to know what this missing angle is, but I tell you that the area is 630. This is 4a.
You have to find the height.
No need to find the height here. So we just use our area formula. The area, which is 630, is a half multiply 52 multiply 25 multiply sine x. So that means sine x would equal whatever 2 multiply 630 over 52 multiply 25. What's that, please? I'm just taking these numbers to the left. Oh, and I took the...
0.9692.
What is it?
0.9692.
0. Point,
9692.
Basically 63 over 55.
or 63 over 65 is a... Okay. As a exactly... I'll write actually the fraction in thanks. Say that again, Naveed.
63 over 65.
63 over 65. Okay.
That's not the angle, so what is
No, that's not the angle, yeah. So we have sine x equals 63 over 65. So if we want the angle, we use sine inverse. 63 over 65.
75.75.
76 if it's to no decimal places, yeah? 76 degrees. Okay, write that down.
step in the exam as well?
Hmm?
Show the step in the exam. Like we got the answer, then do sine x equals the answer, then x equals sine inverse of the answer.
This could happen in the exam. I have actually seen this in the exam 3 times now, as part of a bigger question where they give you the area and 2 of the sides and you need the angle. So the answer should look like this.
So can't I write this?
Yeah.
Can't I just write like x equals sine inverse of 2 by 630 over 50 over 25?
Oh, I see what you're saying. Yes, you could. That's okay, yeah. Yeah. Oh, you'd skip the simplifying of the fractions, fine, yeah. Yeah. Okay. Next now, I just have to give you a little bit of vocabulary. So did you write that down? Yep. Yes, okay. So here, need to go for a second? Yeah. Yeah. Let's go ahead, yeah. Now, this triangle here has a special name. If all the sides are the same.
Bilateral.
No, it's the other one.
The other one.
Equilateral is the triangle.
That's what I said.
Yeah.
It's also one of the 2 equal sides.
We'll get to that in a moment. Now, in this triangle, let me help you remember this. In this triangle, all the sides are equal.
So are all the same.
And all the angles are equal as well.
And all the angles are equal as well, yeah.
60, 60.
It would have to be 60, wouldn't it?
Yeah.
This triangle is called equilateral. And then the other one?
Isosceles.
Isosceles, yes.
Two sides are the same. The bottom are the same.
these two are the same, but this one's not. And so these two angles are the same, and then this one here, not. And that one's called isosceles.
And one on top is always smaller than the bottom. Then there's a top.
Yes. Oh, yeah. Yes, that's fine, yeah. It's important that you know those words because at least once in the exam they've used those words in the question and you need to know that to solve the question. So for example, the question maybe said the triangle is isosceles, but it only told you one of the sides. And some students thought they couldn't do the question because they didn't have enough information. But if they knew the word isosceles, they would know that the other side's the same. Okay? So those are two important words for trigonometry. Equilateral and isosceles triangles. So we basically have three pieces of vocabulary. We have right angle triangle. Yeah, oh that's the other one too. I won't do that one, but yeah, that's the other one. Right angle triangle. What does a right angle triangle mean? One of the angles is 90. We have equilateral, all things are the same, and isosceles is two are the same. And then we've done sine, cos, tan, Pythagoras, and the two area formulas. Okay? Okay, we've still got time. So,
Will we do cosecant and secant?
next semester. I was going to say do the last three, but we'll make it the last two as well. Yeah.
Grazie.
Yeah. So work on those now, and you probably get them finished before we have to go.
Yeah, what about like number 5 and 6 they have to do it?
Yeah, do it in 5 and 6, yeah. Yes?
Let's do it.
Okay. Next week.
Well,
Simon will be next week. No, it will be next week.